Okay, we are going to be looking at quadratic functions. Quadratic functions always have an x squared term in them. So the typical standard form for a quadratic function would be ax squared plus bx plus c. If you remember correctly, when you graph a quadratic function, these make a parabola. And so the parabolas are the U-shaped kinds of things, all right? So if this leading coefficient here, or the term that's in front of the x squared, the a, is greater than 0, which basically means it's positive. So if the a is positive, the parabola opens up, and it will be a parabola that looks something like that. Okay, and if that a value, or the number in front of the x squared term, is negative, it will be a parabola that opens down and looks something like that. Okay, so there's some parts of the parabola that you need to kind of be familiar with, and this mostly should be review, but we'll just make sure that you remember it. So this sort of imaginary line that runs through the center of the parabola and cuts it in half is what's called the axis of symmetry. And that has an equation that goes like this. It's x equals negative b over 2a. And then people always go, well, where do you get the b and the a from? So the b and the a come from right here. The a is the term in front of the x squared, and the b is the number or the coefficient in front of the x. Okay, so that's the axis of symmetry. Where it tops out or bottoms out, this point right here would be called the vertex. And we'll talk about how to find that in a minute. If it has a high point, and I didn't draw this very symmetrically, sorry, but this should be your vertex here when it's a high point like that, okay? In this case, your vertex is also a minimum, but on the right-hand side, your vertex is actually a maximum point, all right? And I think that's what we need to talk about for now. So we're going to go ahead and do a problem and talk about some different ways that we can do this. So I'm first of all giving you a function that's f of x equals x squared minus 6x plus 3, and we will find some different things about it. First of all, we're going to worry about finding our axis of symmetry, okay? So our axis of symmetry we solve, or we get, by using this little formula right here. So to do our axis of symmetry here, you can see, first of all, there's an imaginary 1 right there. So I know that a is 1, b is the number in front of your x term, so b would be negative 6, and c is 3. So if I follow this formula, negative b would be negative of negative 6, so the opposite of negative 6, over 2 times a, which is 1. So I have positive 6 over 2, which gives me 3. So my axis of symmetry is x equals 3. Okay, then I'm going to use that axis of symmetry in order to find the vertex. So I will plug that value back into the equation in order to find the vertex. So my axis of symmetry was x equals 3. I'm just going to carry this down. Axis of symmetry, I'll just go like that, was x equals 3. Okay, I'm going to go ahead and plug that x value in to my function again. So f of x then would be 3 squared minus 6 times 3 plus 3. So 3 squared is 9, minus 18 is negative 9, plus 3 would give me negative 6. So that makes my vertex, my x value is negative 3, which I already had right here. And when I plug that negative 3 value in, my y becomes negative 6. So here's my vertex right here, 3, negative 6. So I can do a couple of different things from this point on. First of all, I'm going to put my vertex on here. So we have 3, negative 6. Because my number in front of my x squared term, or my a right here that we looked at, was positive, I know that this is going to be a parabola that opens up. And so I can sort of follow this little cheat chart that I gave you right here and graph the parabola this way. This will give you some shortcuts. And then I'll teach you some other ways to do this too. But the shortcut would be to go from your vertex. My a value is 1, so I'm going to use this little chart right here, and it does open up. If it was a parabola that opened down instead of going up one, right one, you would go down one, right one, okay? This parabola does open up since my a value is a positive 1. So I will use that chart, and it tells me that the first move is to go up one, right one, and then the next move tells me to go up 3, right one. So I started at my vertex, I went up one, right one, and now I'm going to go up 3, right one. This basically gives me half of the parabola. We know that the axis of symmetry goes through the vertex, and that axis of symmetry cuts the parabola in half. So to find the other points, I can go up one, left one, and up 3, left one, and this is what my parabola will look like. Okay, a couple of other things you can do if you want. You can make yourself a table, and I would do 5 spots, and I would put the vertex right in the middle. So my vertex we already calculated to be -3, -6. And then I would use x values that go down and up from there. So I would go -4 and -5 and -2 and -1. And then you could plug those x values into the equation as well. So I could plug x as -5 in, and when I plug -5 in, I would have to take -5 squared minus 6 times -5 plus 3. And, oops, my vertex is not -3. My vertex, oh my gosh, you guys, I totally screwed this up. My vertex is +3, +6. Oh my goodness. Let me fix this. And I have to fix this. Sorry. My vertex is +3, +6. Okay, so +3, +6. Actually, I did graph it right, but I just, yeah. Sorry. All right, looks like that. When I make my XY table, let's go back to this. Okay, I will put my vertex in the middle, so 3, -6, and then I will go, again, down 2 and up 2 and plug those points in. Okay, so if I want to figure out what my y value is when x is 2, I would plug an x value of 2 into the equation. So I would go 2 squared minus 6 times 2 plus 3, and when x is 2, I get a y value of -5. And you can continue this process if you want. These will be -2 if you want. The other thing you could do is you could use your calculator to help you get some points. And I will just pull this up here in a second. Sorry, this takes just a little bit here. When you put this into your calculator, you can go right to the y equals key. Okay, and my function in this case was x squared minus 6x plus 3. And I can go ahead and graph it if I want to check to make sure that it looks right. So that's one thing I can do. And then I can also go to my table of values, and your table is blue, and to get to it, you'll do second graph. And if you look at that, it gives you some points to plot here. And I want to go the other direction, but it gives you some coordinates to plot that you can look at. I can see that this is sort of the symmetry point on my table. If I look one up from that and one down from that, I'm getting the same value, so I can see that my vertex is there, and it also gives me some coordinates to plot, and you can check it that way too. Okay, so things for you to think about when you do this. All right, so the last thing we need to do in this problem is to talk about its domain and range. And so remember, domain is what your x values can be. That's where you'll take a vertical line and you'll drag it across this graph and see where it touches it. And actually will cross everywhere. Even over here, those blue and green lines would eventually cross somewhere up in space in the upper right-hand corner of the room. Okay, so my domain would be everything. My domain goes from -infinity to +infinity. In set notation, basically my domain is an element in the real numbers. It's any number that we want. And then in interval notation, it would go from -infinity to +infinity. Your range, however, to do that one, you would draw a horizontal line and drag it. And it's not touching the graph, not touching the graph, not touching the graph, not touching the graph. It starts to touch the graph here when my y value is -6, And then when I continue up, it continues to touch even off the screen. So my y value, my range would exist when my y values are greater than or equal to -6, or from -6 up until I hit infinity. Okay? So that's that. And then we'll do one more here really quick just to figure this out. And we'll do this one a little bit faster. But our axis of symmetry would be -b over 2a. So you can see that your a is -1, your b is 4, and your c is -1 if you need it. You don't need it in this case, but that's how it goes. So to find the axis of symmetry, I will do the opposite of b, so the opposite of 4 over 2 times a, which is -1. So I would have -4 over 2, which would give over -2, -4 over -2, which would give me +2. So my axis of symmetry would be x equals 2. Okay, I would plug that into my equation to get the y coordinate of my vertex. So what I know right now is that my vertex has an x coordinate of 2. What I'm needing to find is my y coordinate. Okay, so I will plug the x coordinate in, and that would be negative times 2 squared. Notice my order of operations here. I need to square the 2 first and then multiply it by the negative, because it's not in parentheses like that. Okay, so be careful about your order of operations there. And then I will go 4 times 2 minus 1. When I simplify all of that, I will get 3. Okay, so my vertex is 2, 3. This happens to be a parabola that opens down. So my vertex would be at 2, 3. My a value here is a -1. I'm going to use this row of the chart since it's 1, but because it's actually a -1, instead of going up 1, right 1, I will go down 1, right 1. So I will go down into the right 1, and then my next move tells you to go down 3 and right 1. And obviously if your a values are different numbers, then you'll use different parts to the chart, but that's this. This is my vertex, and it's also my max. Okay, this is what I can say. I can say that my maximum value is 3, that's the highest it gets, when x is 2. Okay, that's what I can say about that. And I actually could take that and drag it right over there to answer that question. The maximum value is 3 when x is 2. All right, again, we'll talk about the domain and range here. If you draw a vertical line for the domain, not very vertical, sorry, but if you draw a vertical line for the domain and drag it across, it actually will touch everywhere. Even over here, they would eventually touch on the bottom left-hand corner, the green and the black line. And so my set notation, again, would be all real numbers. Or in interval notation, I would go from -infinity to +infinity. And then my range, if I draw a horizontal line, it's actually touching down here because the black line would extend. So it's touching, 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 continues to touch all the way, all the way until my y values hit 3. And then after that, it doesn't touch. So as long as my y values are smaller than or equal to 3, it will touch that graph. And so y, set of all y, such that y, oops, I forgot up here to do this, set of all x such that, set of all y such that y is less than or equal to 3. My range would, because you have to go from the bottom to the top, would actually go from -infinity until I hit 3. Okay. Then the question is, what would you do if, because you're going to get this in your accelerated math a little bit, what would you do if I asked you to do this? X squared equals, or x equals y squared plus 5, okay? Here's what you need to know. These are sideways parabolas, okay? They are sideways parabolas. The reason you know they're sideways parabolas is because it's the y that's squared and not the x. If this number right here is positive, it will go to the right. Okay? If this number right here is negative, it will move to the left. This number tells you basically the x value that it happens at. So this right here would be 5, and this right here would be 5, and they should be lined up. Sorry, but they're not. But so for the red one, my domain would go from 5 to infinity, and my range would be all real numbers. On the blue one, my domain would go from negative infinity to 5, and my range would be all real numbers. So you might want to kind of just write that down so that you have that in your notes, okay? And that should do it for this lesson.